E regressamos para a segunda parte da manhã da Oceanic Renewable Summit 2024. Recordamos que podem participar diretamente em todos os painéis através da aplicação de suporte ao evento. Chamamos agora ao palco José Maria Lopes, Manager Director Spain and Wind Europe of Smart Energy, para fazer uma apresentação dedicada ao tema Leveraging Portuguese Offshore Wind Power to Grid and Power to X.
Okay. Okay. So I would like first to thank I would like to thank first APREN for the invitation to make this presentation in the Oceanic Renewable Summit. First, would like to present briefly Smart Energy for those of you who don't know our group. And the main point of this presentation is presenting the synergies that we see between floating offshore and the production of green hydrogen or its derivatives. And finally, just summarizing a bit our activity within the floating offshore landscape in Portugal. So Smart Energy is a Swiss investment group based in Volerau in the south of Zurich, with main operations in Portugal, Spain, Italy, and in Germany, where we are developing our renewable projects. We have also presence in Latin America, Chile, and Mexico, where we are mainly executing EPC solar projects and operation and maintenance. And we have also a commercial office in Abu Dhabi in order to attract investment for our renewable portfolio. The company is a medium-sized group, 400 employees, but with a very strong track record mainly in solar and in wind. We have already implemented about 7 gigawatts in the countries that I have referred to. And we have a project pipeline of projects under development of about 10 gigawatts in solar and wind, onshore wind, and about 2 gigawatts in green hydrogen and its derivatives. We are offering a kind of one-stop shop for investors, ranging from the whole project life cycle from A to Z, from the very beginning greenfield project origination and development towards RTB. Later, we are offering also EPC for solar projects. So in solar, we are able to offer for investors a kind of COD solution. And later, we are also taking care of about asset management and operation of our plants. We have 2 commercial utilities also within the group. One is Muon here in Portugal, and another one in Az in Spain, which allows us to have a direct contact with our customers and closing PPAs between our operating assets and final customers. And the company has moved from solar and wind to green hydrogen, where we started in 2019, developing green hydrogen and derivatives projects, especially dedicated to the sustainable aviation fuels. Moving to the point of the presentation, I would like to start with the target of the European Union for 2030 in terms of green hydrogen production, which is about 20 million tons of production per annum of green hydrogen, out of which 10 million tons are planned to be produced domestically in Europe, and another 10 million tons, the remaining ones, outside of the European Union. The domestic production, 10 million tons, is equivalent to about 100 gigawatt of electrolyzer capacity. And this electrolyzer capacity is equivalent in order to fulfill the additionality principle of the delegated act for renewables, for the production of renewable fuels of non-biologic origin, is about equivalent to 200 gigawatts. Well, Hydrogen Europe is forecasting that this 200 gigawatt will be composed about 125 gigawatts of solar PV, 39 gigawatts of offshore wind, and 31 gigawatts of onshore wind. So thus, offshore wind is already and will be a fundamental pillar for the rollout of the European green hydrogen strategy, with about 20% market share. And if we consider the specific bathymetry of the Portuguese coastal zone, we can think that the corresponding part of these 39 gigawatts will be mainly of floating nature. If we look also at the right part of the graphic, the share for the production of renewables for the production of green hydrogen, the remaining 10 million tons, we see that the share of offshore there is much lower. We are speaking about 9 gigawatts out of 150, so about 6%. And this hints us about one of the main advantages we see in offshore wind, because outside of the European Union, we are not facing the difficulties in land securitization as we are facing in most of the countries in Europe, both for onshore wind and for solar PV. And this is one of the fundamental benefits of offshore wind we see, is in the ability to develop new large capacity in renewables. When looking at the technology side, we think, or we see that floating offshore and both also green hydrogen present different challenges to overcome from a technology point of view. But interestingly, when combining both together into floating offshore to Power-to-X projects, there are relevant synergies which may help to overcome these challenges. One of them, to give you an example, is the costly and heavy grid connection infrastructure that for offshore projects, and especially for floating offshore projects, it is planned to be needed, which might have an impact on the LCOE. Equivalently, for hydrogen projects, we note that the H2 transport and distribution infrastructure will have also a very relevant impact on the LCOH. When combining both technologies together into Power-to-X projects, there are synergies which allow us to reduce the LCOH, to have benefits in the LCOH because of the avoidance of both infrastructure, the grid connection infrastructure for the electrical part and the H2 transport infrastructure for the molecule. And another example is the challenge that we are having when developing H2 projects, especially for developing renewables close and directly connected to the electrolyzer. This is becoming a challenge in many locations. It's very challenging to do this. An alternative would be to supply green power through the grid out of a remotely connected solar or onshore park. But again, here, grid capacity and grid connection capacity for the renewables is also becoming a challenge. So connecting directly a floating offshore to the green hydrogen production is a way to overcome this challenge, and at the same time have a quite high load factor, which floating offshore, as I will show you later, presents. When speaking about offshore Power-to-X projects, we see mainly 3 locations for the electrolyzer. One would be the offshore decentralized location integrated into each individual wind turbine platform, of course at a smaller scale. Second option is offshore location, but centralized into a single platform with a larger scale. And finally, an onshore location integrated within the H2 valley and close to the consumption of hydrogen. 4 main advantages as described. First, the avoidance of grid connection infrastructure, which has a positive impact on the LCOE. On top of that, if we consider a 10 gigawatt rollout plant in Portugal, we could also think in using the same infrastructure, but in the other way around, to supply energy from onshore to the electrolyzer. Of course, when wind is not blowing, ensuring a minimum operating regime for the electrolyzer, and even increasing or boosting the load factor of the electrolyzer with perhaps solar or solar PV profile production. Another advantage is the avoidance of the H2 transport infrastructure, overcoming the land challenge that land bottleneck that I was referring to. And another important factor that Juan Virgilio was mentioning this morning in the first session is that let's say using floating offshore for Power-to-X projects would allow us to increase scale sooner than only using it for grid-connected projects, and as such, of course, bringing cost down for the technology. When comparing these 3 options, we see that the first option, that offshore decentralized option, is a very interesting scalable concept, but due to the smaller scale, we think that this will have drawbacks in terms of CapEx and OpEx, not only because of the smaller scale of the electrolyzer, but also of the auxiliary systems for the electrolyzer. Of course, the complexity of the H2 pipeline, collecting the production of the different small electrolyzers. So we see this more as a kind of transit solution toward the second one, which is, in our view, the preferred option in terms of CapEx and OpEx. It is also logistically optimal, especially for the transport of derivatives for using the same platform for the maritime sector. And of course, the main drawback is that this solution might have a longer term to become commercially available because of the technology is not ready as of today. The third location is the onshore location. Has mainly the advantage of being integrated into the H2 valley, so closer to the consumption, closer to the industrial off-takers. It has also another main advantage that the technology is already available. Technology is ready as we are using it for our onshore projects. And that also we could think about using PV in order to increase the load factor and boost the load factor. On the other hand, the cost of the connection infrastructure from the floating offshore part to electrolyzer might have, of course, an impact on the LCOE. To end up this second part of the presentation, I would like to highlight the strength or the synergies that we see looking at the density of the maritime traffic density in Portugal. And we see that Portugal is hosting one of the heaviest and largest shipping routes worldwide. And this is only 100 to 120 kilometers away from the shore. So this could be a highly interesting opportunity for the second concept that I was presenting previously, namely the offshore location of electrolyzers into a single platform. This platform could even be used as loading dock for the export of H2 derivatives like methanol or ammonia. To finalize the presentation, I would like to highlight what we have been doing within ABREN's working group. We have been actively participating, Smart Energy, in the working group of ABREN, supporting the interministerial working groups who are defining the regulatory framework for the rollout of offshore renewable energy in Portugal. This working group was created end of 2022, and in 2023, the government released first draft in May 2023 of the areas allocated for development of such projects, 10 gigawatt rollout. And in October 2023, the PAER was released for public consultation with small changes in the areas allocated for the development of such projects. We are speaking about 10 gigawatts in different areas and about a usage of 3,200 square kilometers, density of about 300 square kilometers per gigawatt. A brief summary of the last steps in the last months, in the last half a year that we have been in which we have been participating is the expression of interest, which was launched by the government in October 2023. There was a huge interest in participating in the auctions. About 51 companies or consortiums expressed their interest in the Portuguese auctions announced. There was later a dialogue session with developers organized by the government here in Lisboa on the 11th of January. And later there was a questionnaire which we have received, all these 51 companies, let's say, in which we could provide our inputs towards the future regulatory definition of the auctions. This was late February, beginning of March. So now we are expecting with anxiousness that the new government is now releasing the next steps, especially the pre-qualification process for the first auction and the first auction to take place, if possible, this year. We have been always speaking about the two models. I think Pedro and Juan Virgilio were speaking about them in the first session. So one state auction for the allocation of the three main rights, the seabed rights, the grid connection right, and the CFD support, or alternatively a two-stage auction, which is preferred by us and by most of the promoters, having first the seabed right allocated and then later the grid connection right and CFD support. Of course, we would welcome that part of this capacity is also allocated for Power-to-X projects, but for the time being, it seems that the full 10 gigawatts will be allocated for grid-connected project. And of course, also, as discussed this morning, an important aspect to consider is the need for the development of the whole supply chain, which will take time and which has to run in parallel: ports infrastructure, vessel infrastructure, manufacturing capacity for platforms, and for wind turbines. Portugal has decided to go for a fully centralized approach in terms of seabed definition, in terms of integration of this whole 10 gigawatts into the HV transmission network. And I think following there will be a very interesting session about this aspect. And the three first zones which have been selected by the government or which have been announced for the first auction, which are Viana do Castelo, Leixões, Figueira da Foz, as most of the developers we have been studying there, also for potential Power-to-X projects. And we came out with quite decent load factors, high load factors as expected for the production of green hydrogen in the range of 41 to 43%, depending on which area. And finally, to end up, well, summarizing, we have presented the high potential that we see in floating offshore for the production of green hydrogen and its derivatives. We see a lot of synergies and potential. Of course, there is an urgent need to clarify the regulatory framework governing the auctions, and we as developers, we need certainty, mainly in these aspects that I am listing here, mainly in how this is going to be integrated into the HV grid infrastructure, how the required supply chain is going to be developed, and this is going to happen timely for us, and also how the regulatory permitting process will be defined, and especially how the timelines are going to be respected. I think this is also essential to reduce the risk perception for us, and also to allow that the CFD levels that we were commenting also this morning are as low as possible, or not as high as expected. And that's all. Thank you very much for your attention.
Gracias. Agradecemos a apresentação a José Maria Lopes e avançamos para o último painel da manhã. O painel Creating a Sustainable Grid Design for Oceanic Renewables procurará perceber como evoluirá o desenho de rede para receber os futuros projetos eólicos offshore. Antes de avançarmos para o debate, vamos ter duas apresentações iniciais. Chamo ao palco Belén Segura, da ERE, Rede Elétrica de Espanha, para fazer a sua apresentação.
Good morning, everyone. Thanks for inviting me to this very interesting event. I'm Belén Segura from Red Eléctrica, the Spanish TSO. I am working in the Network Development Department since 2010. I've been involved as well in the different working groups within ENSOI Association, and during the last year I've been the responsible of the Atlantic Offshore Grid report of that has been developed within ENSOI Association. So today my idea is to show you an overview of these offshore network development plans developed by ENSOI. And for that, I would like to start with a quick introduction to give you some context. Then I will explain how these ONDPs integrate within the 10 years network development plan exercise. After that, I will give you some ideas about how has been the approach or methodology applied for this ONDP and the main findings at European level. And finally, I would like to focus on the Atlantic Offshore Grid main results. So, since, as I think all of you know or may know, since June 2022, the European Commission established a new tender regulations in which it was established that under ENSOI mandate should develop the offshore network development plans by 24th January of this year. So in January this year, ENSOI published this package that is composed by different reports, not only one, but 5 reports dedicated to sea basin results, 1 report dedicated to pan-European results with high-level messages, 1 report dedicated to that include details on the methodology applied, and another report, of course, related to stakeholders' engagement. And additionally, I've been also public a visualization tool that I encourage you to visit because it includes quite interesting figures to understand the results. So the ONDP, this plan is part of the TYNDP, the 10 years network development plan. This year has been produced separately. It has been done this exercise separately from the TYNDP due to the legal mandate from the European Commission to be public in January. But in the following exercise, for the TYNDP 2026, the ONDP will be integrated in the phases that are developed within the TYNDP. These phases are mainly four. There is first phase defining the scenarios, the plausible futures that will be with the same probability in order to see what can be in terms of renewable energy capacity, in terms of decentralized, more centralized. After defining these scenarios, then the TYNDPs focus on analyzing, identifying the needs. And in this stage, the ONDP will be integrated with the TYNDP. So these needs will be not only as onshore or storage, but also with offshore, in terms of offshore needs. After that, project promoters propose projects in order to be in accordance with that needs. And finally, for the projects that have been included in the TYNDP list that are accomplished with the TYNDP criteria, then a CBA assessment and cost-benefit analysis is done. This analysis, all these analyses, serve as a basis for the project common interest list that, as you know, is the European Commission is the responsible for this exercise. So in this figure, you can see what are the member states non-binding agreements in terms of offshore targets that are the base for the development of the offshore network development plans. You can see that higher numbers, so that you can see these targets by 2030, 2040, and 2050. So the higher numbers can be seen from the North Seas and Baltic Seas countries. But after that, in the Atlantic Offshore Grid Sea Basin, you can see that it is expected to have 6 gigawatts of offshore wind generation by 2030, 26 gigawatts by 2040, and 44 gigawatts by 2050. What has been the main findings on the approach considered for the development of this ONDP? First of all, the approach or methodology can be summarized in a very briefly, 4 steps. The first step is dedicated to the creation of the starting grid. For the development of these ONDPs, the scenarios that has been considered are based on the previous TYNDP, previous 10 years network development plan coming from the 2022 that has been adjusted, including the offshore targets that has been provided by member states. And additionally, the demand has been also increased in order to consider the future increase of the electricity in the energy system. Once we have these scenarios, we have to define the starting grid that is the infrastructure connection of the generation radially to the respective countries, and additional those hybrid projects that have been already planned. So the starting grid is something that is considered matured. After this definition, then identification of expansion candidates is done. There are 2 criteria for defining. First criteria is TSO interest, and the second criteria is for the geographically proximity among the different offshore nodes. The third steps, once we have these candidates, then a linear optimization is developed. This linear optimization consists of expanding or finding those corridors that produce less cost to the system. And finally, with these results, then we have the expert view from the regional groups that will have their expertise to have the final results. In the following figure, you can see the results at pan-European level. Green lines are the existing or the starting grid, and the orange lines are the identified corridor that have been produced by this exercise. As you can see, there are more corridors are identified in the North Sea areas, while in the other south areas, countries and basins are expected to have more radial corridors. We are talking about corridors, are not projects in this exercise, and because all of them are not yet materialized into projects. Okay. What are the benefits and challenges of the offshore development? Most of you know that main benefits, of course, are the energy security increase. Having a more meshed or redundant connections will give more energy security to the energy system. Additionally, we will have a price convergence that is one of the main pillars as well from the European Commission. The development of the offshore will also allow a better allocation of utilization of offshore renewable energy. But on the contrary, we have challenges, and these challenges are in terms of system risks. What are the system risks that will face the future is something that will have to be included in the corresponding codes and guidelines. Additionally, there are some operational challenges as this is totally new. The operation of this kind of ABDC is something totally new. We have a challenge related to the offshore risk development itself, because it will require very high coordination among the different actors that are involved, suppliers, TSOs, member states, and so on. And additional challenges are related to the infrastructure supply chains that nowadays we can see that are a bit tension, ports availability, environmental impact, flexibility, and so on. In this slide, I wanted to give you also some results at pan-European level, talking about that two different technology evolutions has been considered. First one, a more conservative, is that supposing that there is no evolution, no availability of DC circuit breakers. That means that converter stations are needed per each HVDC cable, and that will mean at the end more expensive solutions. With this first view, we reach 13 additional hybrid corridors are identified with means 14 gigawatts of capacity and a total cost of 32 billion euros. But if we consider this, that the DC circuit breakers are available in the future by 2040 and 2050, then this will translate into 34 additional hybrid corridors, 44 gigawatts of additional corridors, of capacity, and a total cost of these additional identified corridors, 42 billion euros. And finally, for giving you some pan-European vision, is that this investment, the total investment cost of the full package of the European will mean around 400 billion euros, and a route length of more than 50,000 kilometers, more than 150 DC converter stations offshore, more than 120 DC converter stations onshore, and a lot of more than 30 DC circuit breakers. So now I would like to focus on the results of the Atlantic offshore grid. Here you can see, well, first of all, the people that were involved, not only me, but several people from the different countries, Portugal, Spain, France, and Ireland. You can see on the table below what were the targets defined by member states. On the left side, you can see what first was declared by member states, and then what it was considered finally by ENTSO-E, and you can see a higher difference in the data of Portuguese, that these data were provided by member states in January 2023, but finally there was some adjustments by March, and these 10 gigawatts that were expected by 2030 at the end were corrected by 2 gigawatts. Okay. So now you can see which is the evolution of the location of these member state targets. among the different time horizons. So you can see there is an evolution for the radial installations by 2030 to the first hybrids by 2040 and 2050, mainly in Ireland and France. And to achieve these targets, a speed of installation less than 1 gigawatt per year will be needed by 2030. By this speed, we'll need to increase by around 2 gigawatts per year in the next decades, 2040 and 2050. The main findings in the Atlantic offshore wind sea basin has been that only one corridor has been identified between France and Ireland of 700 megawatts capacity and 500 kilometers. We have to take into account that the starting point were as I've said before, the TYNDP 2022 scenarios that were considering onshore capacity between Spain and France and Spain, Portugal higher than the one that we are considering, for example, today. And as this report will be updated every 2 years, depending on the scenarios that will be analyzed in the future, maybe new corridors will appear in the following versions of the ONDP. As you know, as has been mentioned also here before, the coast, the Iberian coast and the Atlantic, in general the Atlantic coast, are characterized by deeper, very deep water sites. And for that reason, the renewable energy, the offshore renewable energy development is quite dependent on the floating technology evolution. And last but not least, I would like to also highlight the maritime spatial planning that allows for a more optimal use of the maritime space. And in that sense, talking about this maritime spatial plans, in the previously debate has been discussed the importance of the biodiversity. These reports include 2 chapters to this maritime and spatial planning, and with information about, in all the countries that forms the Atlantic offshore sea basin, have approved or adopted each marine spatial planning or an equivalent study. For example, in France, the South Atlantic or North Atlantic basin strategy was approved in 2019. In Ireland, the North Seas Energy Cooperation Study was approved last autumn. In Portugal and in Spain, the marine spatial planning has been adopted in 2019 and 2023, respectively. The 3 main messages that covers all of these marine spatial plannings are focused on that offshore wind development should be done without affecting the landscape and cultural heritage integrity. Also, of course, taking into account protected areas. For that, an environmental impact assessment is needed in order to take into account birdlife, wildlife studies, and so on. Additionally, the routes to land for generation will be designed to minimize the marine space occupied. And with that, I would like to thank you because this is all I wanted to comment to you. Thank you.
Graças. Passamos agora para a segunda apresentação, desta feita de João Peças Lopes, professor catedrático na Faculdade de Engenharia da Universidade do Porto.
Muito bom dia a todos. Em primeiro lugar, dizer-vos que e agradecer à PREN o convite para estar aqui, dizendo-vos que aquilo que vou apresentar são alguns dos resultados de um trabalho que a PREN nos encomendou aqui há algum tempo e que visa identificar soluções de reforço da infraestrutura da rede de transmissão devido ao aparecimento de grandes parques eólicos offshore em Portugal. Os objetivos do nosso trabalho estão ali descritos, portanto, nós procuramos identificar as soluções técnicas, fundamentalmente em termos de grandes corredores na infraestrutura da rede de transmissão, que permitam ligar os grandes volumes de produção eólica offshore num horizonte temporal de 2040. Portanto, ou seja, para além de termos analisado soluções intermédias, por exemplo, 2030, onde admitimos outro volume de integração, nós consideramos sobretudo o horizonte temporal de 2040 e admitimos a hipótese de as soluções poderem ser em muito alta tensão, corrente alternada, ou a muito alta tensão em corrente contínua. E, portanto, como já disse, este estudo visou identificar os principais reforços de rede necessários para resolver este problema. Devo aqui dizer que este trabalho só foi possível devido à colaboração da REN, que nos disponibilizou a rede em formato PSSE para podermos fazer os estudos e que essa rede corresponde à rede do PDIRT 2022-2031, adicionado dos investimentos necessários para acomodar a produção solar fotovoltaica que resulta de acordos que, entretanto, foram celebrados antes de 2030, até antes de 2030. E, portanto, basicamente, a infraestrutura de rede que nós consideramos é aquela que está aqui descrita nestas figuras. Em termos da cenarização, porque foi preciso fazer uma cenarização da produção e da carga do sistema, e como já disse, nós centramos a nossa atenção no ano 2040. Aquilo que fizemos foi utilizar os dados que foram também definidos no relatório de monitorização de segurança de abastecimento e que estão identificados naquela coluna ali e naturalmente que isso depois repercutiu-se em termos de volume de potência instalada pelas diferentes tecnologias e portanto, com uma forte presença de produção eólica offshore que, para o ano que foi simulado, 2040, foi no valor de 10 gigawatt, portanto, de potência instalada. A localização dos parques eólicos offshore é conhecida e que já foi, enfim, dada a conhecer há algum tempo, portanto, com uma parcela significativa na zona de Viana do Castelo, depois na zona de Leixões, Figueira da Foz, Ericeira e finalmente a sul, em Sines. E a distribuição das potências que consideramos está descrita precisamente naquela tabela que ali podem ver. Naturalmente que tivemos que considerar um conjunto de barramentos de interligação na rede nacional de transporte e o que fizemos foi escolhê-los pela proximidade relativamente a estas produções eólicas offshore que aqui estão identificadas. Fizemos, sobretudo, e para aquilo que aqui venho mostrar-vos hoje, fizemos, sobretudo, uma análise em torno de dois grandes cenários. Um cenário de inverno, de período de ponta, portanto, maior consumo, e um período de inverno úmido, ou seja, com muita produção hidroelétrica, portanto, o que significa que este cenário é um cenário de por volta das 8 horas da noite, num dia de inverno, portanto, sem produção solar fotovoltaica, mas com uma produção significativa de produção eólica offshore, na casa dos 70% relativamente à potência instalada, e uma vez que nós sabemos que existe uma correlação muito forte entre aquela que é a produção eólica onshore e offshore, adotámos para a produção eólica onshore também um fator de cerca de 70% relativamente à potência que era injetada na rede, mas que estava distribuída ao longo da rede nacional de transporte. E depois considerámos um outro cenário de verão, agora num período seco, portanto com muito pouca, ou até mesmo quase nenhuma, produção hídrica, e portanto com uma produção solar fotovoltaica significativa, mas que naturalmente se traduziu também numa menor produção eólica, quer offshore, quer onshore. Nós desenvolvemos um algoritmo de procura de reforços na rede. Esse algoritmo foi um algoritmo de pesquisa orientada que visou procurar soluções possíveis e procurando exaustivamente ligações entre barramentos até 300 km de distância, e para isso utilizámos um modelo DC para nos facilitar o processo de pesquisa. Naturalmente que depois de encontradas as soluções, o problema era resolvido em AC, mas portanto a procura das soluções era feita em cima do modelo DC para ser mais rápido e fácil obter as soluções. O algoritmo está aqui descrito apenas para vos dar a conhecer do esforço que foi feito nessa linha de trabalho, mas obviamente que não vou descrever em detalhe o que aqui está. Quando definimos os cenários de inverno úmido, foram identificadas, aliás, devo dizer, quando definimos os cenários e depois quando começámos na procura das soluções, procurámos utilizar uma metodologia de análise de contingências N-1 e N-2, de acordo com o que está definido regulamentarmente em Portugal, e eu identifico-vos aqui as contingências que foram identificadas nos estudos que então fizemos. E, portanto, fazendo todas as contingências N-1 e N-2 que estão definidas regulamentarmente. E há claramente ali dois eixos, Ferreira do Alentejo Sines e Sines Pegões, que são eixos onde há uma probabilidade muito grande de ocorrência de sobrecargas das linhas na sequência de um grande número de contingências, 502 e 504 contingências. Quando lançámos o nosso algoritmo de procura de soluções, este foi o resultado. Ou seja, nós identificámos várias alternativas, porque aquele algoritmo gera várias alternativas que podem ser ordenadas por exemplo, a primeira alternativa, a alternativa A1, que corresponde a desenvolver basicamente um corredor entre Lavos e Sines, em muito alta tensão, 400 kV, duas linhas em paralelo, e um outro reforço que corresponde ao corredor Ferreira do Alentejo-Sines, também com o mesmo tipo de solução, e depois uma outra possibilidade, uma outra alternativa, a alternativa A2, que correspondia a um reforço entre o Pego e Sines, e também o reforço do eixo Ferreira do Alentejo-Sines. Quando fizemos esta análise, procurámos também avaliar da possibilidade de utilizar linhas em corrente contínua, portanto, mais ou menos 500 kV até 1200 megawatt de capacidade de transporte. E aqui deixem-me dizer-vos que a nossa preocupação em utilizar sempre uma solução de linha dupla foi no sentido de garantir a redundância destes circuitos e, portanto, garantir que depois, ao testarmos novamente a análise de contingências N-1 e N-2, não existissem problemas. E identificámos, contudo, que, mesmo assim, continuavam a existir alguns congestionamentos na sequência de algumas destas contingências, mas aquilo que identificamos é que estes congestionamentos são congestionamentos de sobrecarga relativamente baixa, o que quer dizer que, e aqui vou introduzir uma ideia nova, o que quer dizer que uma parte destes congestionamentos pode ser resolvida por um modelo de gestão ativa, dinâmica da rede, que passa por ajustar as produções temporariamente, durante períodos de tempo relativamente curtos, ou até mesmo reconfigurar a rede em algumas situações, uma vez que a reconfiguração acaba por estabelecer novos caminhos com outras impedâncias possíveis portanto, isto pode ser resolvido não necessitando de, enfim, reforçar todas as soluções onde identificamos congestionamentos que são congestionamentos relativamente baixos. No cenário de verão, e há pouco esqueci-me de dizer que estamos a considerar em termos de carga 10 gigawatt de carga, a que acrescem 8 gigawatt de consumo na zona de Sines, portanto, ou seja, estamos com cenários de 18 mil megawatts, portanto, admitindo um crescimento industrial significativo no país, e em particular na zona industrial de Sines. Portanto, relativamente, voltando à apresentação, relativamente ao cenário de verão, as contingências que identificámos foram aquelas que estão ali, naquela figura, o que nos levou a que, na procura das soluções de reforço do sistema, identificássemos também várias alternativas. Apresento-vos aqui duas apenas. A alternativa A1, mais uma vez, sublinhe-se, a alternativa A1 é sempre o eixo Lavos-Sines e o eixo Ferreira do Alentejo-Sines. Ou seja, esta solução é uma solução que precisa de ser adotada. Relativamente à alternativa A2, haveria a possibilidade de, portanto, fazer uma ligação Sines de Ivor e Ferreira do Alentejo-Sines. Aqui também analisámos a possibilidade de, em vez de recorrermos a ligações em muito alta tensão, corrente alternada, portanto, estou a falar de 400 kV, admitirmos ligações nos mesmos eixos, mas agora em corrente contínua, mais ou menos 500 kV. E, com estas soluções, nós não tínhamos quaisquer congestionamentos nas linhas na sequência das contingências N-1 e N-2 que o regulamento da rede de transporte exige que se façam. Já agora, gostava também de deixar aqui uma reflexão, uma vez que esta solução HVDC, a solução em corrente contínua, pode ser desenvolvida de duas formas, sob o ponto de vista físico, ou seja, pode ser desenvolvida a partir de linhas híbridas, corrente alternada, corrente contínua, linhas aéreas, que exploram corredores já existentes, ou então explorar ligações em cabo submarino, e aqui, precisamente aproveitando aquilo que a Belém apresentou há pouco, o 10-Year Network Development Plan 2024, que o NZOE publicou recentemente, tem uma ligação em HVDC da Alemanha até ao norte da África, que passa pela costa portuguesa, e aqui a solução precisamente poderia ser a de explorar esta interconnector para que ele fosse simultaneamente uma ligação de interconexão entre áreas, mas também se fosse híbrida, no sentido em que poderia fazer o harvesting da produção de origem renovável ao longo da costa portuguesa e, portanto, com isto, resolver o problema. As principais conclusões que aqui vos queria deixar estão aqui, descritas. Portanto, não restem dúvidas que a ambição de ligarmos 10 gigawatt de potência eólica offshore ao longo da costa portuguesa vai sempre criar problemas de stress na operação do sistema elétrico português, nomeadamente quando se simulam as contingências N-1 e N-2, que estão definidas regulamentarmente. Algo que me parece extremamente importante é que a rede portuguesa, daquilo que foram as simulações que fizemos, identificámos que só começamos a ter problemas que são verdadeiramente críticos a partir de 2,5 gigawatt para cima. Portanto, até 2,5 gigawatt a rede acomoda mais ou menos esta produção eólica offshore. Foram identificadas soluções com corredores em HVAC, portanto, em corrente alternada 400 kV e HVDC mais ou menos 500 kV. E estas soluções permitiram resolver a maior parte dos congestionamentos que resultavam das contingências N-1 e N-2 nos cenários de análise. E aqui sublinhar também que alterações aos cenários que foram estudados podem conduzir a pequenas variações nos resultados que tivemos, mas isso não modifica aquilo que são as soluções principais, as grandes corredores, as grandes linhas de força de desenvolvimento. E finalmente, deixar aqui também uma mensagem muito clara, que é alguns investimentos adicionais que possam eventualmente parecer necessários no sentido de eliminar congestionamentos que possam existir no sistema, mesmo com o desenvolvimento destes corredores, podem, na maior parte das situações, ser geridos através da gestão dinâmica da rede, que não é mais do que colocar em prática aquilo que o Decreto-Lei 15/2022 já tinha definido, e em que tanto os operadores de sistema, nas suas fases de planeamento como de operação, têm que planear, têm que começar a desenvolver no sentido de encontrar soluções que não necessitem de um reforço da infraestrutura de rede e que permitam, desta forma, acomodar esta produção. Claro que quando eu estou a falar disto, estou a falar de eventual corte de produção de origem renovável, em particular eólica offshore. Mas, mais uma vez, sublinhar que serão sempre cortes limitados, temporalmente, e que evitam o reforço significativo na infraestrutura de rede de transmissão. E com isto termino. Muito obrigado pela vossa atenção.
Após estas duas apresentações iniciais, passamos então ao debate. Convidamos o professor Peças Lopes a sentar-se para o debate e chamamos para o acompanhar na discussão Georgios Rogdakis, da Ocean Winds, Manuel Costeira da Rocha, da Smart Energy, João Conceição, da REN, e o moderador do painel, o jornalista e editor de Economia do Expresso, Miguel Prado.
Good morning, everyone. First of all, thanks to APREN for the invitation for this session. It's a pleasure to be here talking about this issue, which will be meaningful for Portugal in the coming years. I would like to say also that if you have questions for this panel, we'll have some minutes in the end to receive your questions through the app you already know. And so I would like to start with Professor João, because of your presentation and the technical limitations of the grid. Should we limit the prospects of offshore wind in Portugal to 2 gigawatts to avoid these problems or not?
I don't think so. So what I tried to explain was that the network is capable to accommodate up to 2 gigawatt without the relevant needs of reinforcement of the transmission infrastructure. But of course, this should not be a reason to limit the deployment of offshore wind power. And of course, there are a lot of plans for the increase in load, industrial load, new industries that will bring so new jobs, new opportunities for the development of the Portuguese economy. So, and for that, it's necessary green energy, green electricity. Of course, we can further develop solar PV generation, but as we all know, solar PV will not allow for a factor of utilization so high as wind offshore provides. So typically 4,000 hours per year or even more. So clearly, offshore wind energy brings an opportunity for the deployment, for the development of those sectors of the Portuguese industry that can be fed with green electricity. And of course, this is only possible if we create the capability to produce that energy. Of course, this is always the issue of the chicken and the egg, but so we have to find out a compromise here and see how the industry is going to develop and at the same time how the deployment of this offshore wind energy can provide that also the contribution to feed those needs of that industry. And of course, in order for that to take place, we need the infrastructure of the transmission system because this is not feasible in other way.
Okay.
Yeah.
João Conceição, I suppose that REN would be highly interested in investing huge amounts of money in the grid. It's your business. Looking into Professor João Peças Lopes' presentation and the technical challenges of the grid, are you concerned about the capability of the country to move on with the plans for having at least 2 gigawatts by 2030 and 10 gigawatts by 2040?
Well, first of all, I would like to thank the opportunity to be here, thanks APREN. And allowed me, Miguel, to make a slight correction on what you've just said, because REN is obviously a private company and our business model is based on our investment, but we don't just do investment for investment. We do the investment when it's needed, because we strongly believe that this investment needs to be sustainable, and sustainable at different levels, at a technical level, but also at the economical level. We don't want to have in our grid over-investments or being accused of being developing over-investment. I would pick what Professor Peças Lopes just said, because the issue here is that the energy system gets a high level of complexity in the sense that we have different variables over the table at this moment. And the offshore, in our view, should not be seen independently of all the other variables. And what I mean by that is that we have an expectedly sharp increase on consumption within Sines area. And this is no longer, in our perspective, just some intentions, because these developers have paid guarantees. They have paid a huge amount of money already, signaling that they are looking serious to this project. And if this happens, we will need energy. Otherwise, we will need to be highly interconnected, even more than what we are today with our Spanish friends. And of course, we will be dependent on what's happening in Spain. So This development of the wind offshore needs to be correlated with the other developments that are happening within the energy system in Portugal.
I understand, but do you have at your company the needs, the people and the knowledge to build a completely new subsea infrastructure from scratch? It's a new business for you, or not?
It's definitely a new business. We have a very small example of linking a very small project, as you know, from wind offshore. Of course, what we are speaking here, it's a completely different scale. We need to develop some skills, namely in terms of operation of this type of infrastructure, but this is not something that we don't believe that we are not able to do it. We are able to do it. We did this small example on time and on budget when everyone was saying that it was very difficult, and we strongly believe that we are able to do the next step on this 2 gigawatt development, which is foreseen to be the first step forward on the wind offshore.
Georgios, good morning. Let me ask you about the cost of building a grid to support offshore wind. In ocean winds, I suppose that you analyze every time the evolution of the costs. How much money does it cost to build 1 kilometer of cables, for instance?
Yeah, first of all, let me thank you for the opportunity to be here in this panel. I think it's very difficult to quantify the cost per kilometer because it depends on quite a lot of things. When we are looking into the options of connecting offshore wind farms to the grids, it really depends on the model of each country. There are countries that we need to bring the grids all the way to offshore, which means that we need to build the transmission, and there are countries where the grid is coming offshore. Thereafter, we need to analyze, in each case, what happens. We need to assess the connection point, which is also very, very important, how close it is. And depending on this, we need to make a techno-economic analysis to understand voltage levels that we connect, technology, AC or DC, and then understand how we can solve this problem. What we have seen, it costs, of course, but what we have seen in the past, since the beginning of offshore winds, back in early 2010, we could see that the costs were high, they were going down, and now we see that they're coming up again due to the whole macroeconomic situation. But this is not something that we don't expect that this will last for a long time. It will stabilize and will start coming down again.
Okay. Manuel, regarding this issue of the costs of building this new grid and the infrastructure to support the development of offshore wind and other oceanic projects, are you concerned about this topic? Can we afford these costs as electricity consumers?
Well, I think that, first of all, we must assume that there is a decarbonization need that needs to be implemented. And we start from this, okay? And talking about challenges, even permitting and financing and implementing projects onshore is also a challenge nowadays. So we are now doing our best to establish a green hydrogen economy based in onshore projects, and the challenges on permitting these projects is also huge. So talking about the challenges of the offshore projects is of course something that we have to take into consideration, but we should not forget that also onshore we have this kind of challenges, okay? So we have to be very practical. Trying to decarbonize means that we have to replace assets that are based in fossil fuels and then invest in green assets. It is one of our, let's say, biggest concerns and our core business. And if we think about about fossil fuels, a huge part of the investments are done offshore. So if we are sponsoring fossil fuel activities, and it is happening everywhere in Europe, for example, so if we are sponsoring fossil fuel activities that are placed offshore, we should be clever enough to find ways to move it and start also sponsoring green assets that are located offshore. So we need and we can afford to pay it, definitely. And we have to be optimistic towards this decision. Of course, we have challenges in terms of technology, in terms of permitting, business models, supply chain. It was already presented this morning, but we are clever enough to manage this, I believe. So if there is a strategic vision towards decarbonization, with the knowledge that we have, and in Portugal, for example, we have universities that are, let's say, available to do this kind of studies, like Professor Peças Lopes presented to us the panel before. So we have know-how in Portugal, we have know-how in Spain, we have know-how in Europe that could be the know-how needed to really implement these projects offshore. And I spent much of my life in Africa, and Nelson Mandela said it looks impossible until it's done. So I think that we are now at this stage.
João Peças Lopes, you mentioned in your presentation two main projects that would be needed to deal with the overload and the contingencies you identified in your study. What do we need physically in the country to receive the output of 2 to 10 gigawatts of offshore wind? Regarding substations and the extension of new lines in onshore. So what is needed to deploy to have a balanced grid in the future?
Well, so I believe that you are talking about the corridors that go from Lavos to Sines, and between also Ferreira do Alentejo and Sines. These two corridors, they always appeared as solutions for the problem that we have on top of the table. And of course, this means that it's necessary to develop those corridors of lines. By the way, these are double lines. So because of redundancy issues, as I mentioned during my presentation. Of course, the big problem there will be the permits to build all those lines. But it's not only lines, it's also substations, as you mentioned. So it's necessary to create the substations that will make the interconnections not only with the existing infrastructure, but most important, to the offshore wind facilities. This is something that we have not addressed in this study. We will do it later. But at the moment, we were only looking at the way how to develop the transmission infrastructure in order to accommodate all that generation. And of course, this means that these infrastructures, when being built, they have impacts. And they have somehow some negative impacts on the landscape, even with the populations that will not accept easily the development of these solutions. But of course, at the same time, it's also an opportunity to develop the economy, because it will be necessary to have the people and the workers with the capability to develop those solutions.
Besides those two corridors that you identified, won't we need additional lines to receive the energy coming from the offshore wind farms? Because they are close to some points of high consumption in the country, but we'll have in Sines a great area of industrial consumption in the coming years. So besides those two corridors, would we need more investment or not?
Oh yes, of course. In the substations that will receive the offshore wind energy, so of course, and the cables, and also it is necessary to take decisions regarding where to put the substations, because of course, so the electricity will be generated offshore and will be connected typically to feeders at 63 kV, and this means that you have to then to pass from 63 to 400 kV, and of course there is the need to decide whether these substations are going to be installed. Are they going to be bottom-fixed substations or floating substations? And still, regarding floating substations, there's a lot of work to be done, because only 2 pilots exist in the world at the moment. So there's still some way to be done from the technical point of view. And of course, because if we put those substations very near to the coastline, so this means that we also increase the losses in the system. If not, it is better from the efficiency operation of this solution, but it will increase the costs of investment for those substations being floating ones. But of course, and also in the area of Sines, but better than me, Mr. João Conceição can describe how challenging will be to connect all these 8 gigawatts in the area of Sines, and the number of additional substations that are required around Sines just to receive and deliver locally all this electric energy.
João Conceição, before those challenges in the field, we would also have to take into consideration the political priorities. From what I've seen from this new government, I haven't seen plenty of interest for offshore wind, as we saw with the previous government. Are you concerned that there won't be in the country in the coming months a great political support for this topic that we are discussing right now?
Well, obviously, what you are asking, it's an important question. To answer directly to you, what we are concerned in REN is about security of supply on the first point. The government might have a different perspective, and we believe internally in REN that we are not policy decision makers. We are policy decision implementers. So we will work with the guidelines that is set within the energy policy in Portugal and the energy policy in Europe. The signals that we got so far from the government is that they are totally keen in continue this endeavor of implementing the European energy policy, and there are signals that that there is a continuity in terms of development. Of course, it's more than acceptable. I think we would all find strange if a new government would not stop to think and to make their own decisions. That's perfectly normal. What we have to understand is that, as I tried to explain before, we have to see this now like a full puzzle with different small pieces that only make sense when it's all integrated. And if you see a puzzle and you see a small pieces, for you it doesn't say much. But when you put all together, it makes an integration, it makes sense.
Some developers have projects to have green hydrogen production offshore. Would it make sense, in your opinion?
That's why I'm saying it's about the issue of the puzzle. We should not look to the different components individually, but we should look it all together. We should look at if there is going to be a push or not in terms of hydrogen. If there is, we will need extra capacity to generate electricity to supply this hydrogen. We should understand if we need, if the synergy industrial development is going to happen or not. The signals that we are getting is that it's going to happen. And like Professor Lopes was saying, only that, independently of having offshore or not having offshore, it will require a significant amount of investment within the existing onshore grid. Then we need to have a decision on what is the model that the government believes to be the best model to connect this wind offshore. If it's like Professor Lopes was saying, it should be the network operator that should bring the grid into the sea and to collect the different developers within the sea, or on the other hand, if are the developers that are responsible to connecting the points on shore. Each model is possible. Each model has their own advantage and their own disadvantage. One is probably more expensive from the grid perspective, but has the advantage of a better optimization of all these connection points, a better optimization in terms of permitting and licensing, and so on. The last point I would like to say is that what is the economical model? Because Professor Lopes mentioned, and he's totally right, that we can solve these problems with the dynamic management of the system management and then with a dynamic planning of the grid. But there is a catch on that. Then the catch is that we will have to be allowed to curtail. And
you already did it.
We did it, as you wrote in last week. We had a funny week last week where our dispatchers they had to do a strong curtailment. If I'm not mistaken, an historical strong curtailment never seen in the Portuguese system. But the good news or the bad news, depending on the perspective, this is the new reality. This is what is going to happen when we have renewables above a certain level. This curtailment, allowing a higher level of curtailment, of course, it will imply that we can manage the grid in an optimized way, substituting or replacing grid elements that cost money with impacts on the business model of the developers, because if we will have a problem, we will curtail.
Who will invest in those conditions?
The investors that believe that this investment has the necessary returns
with zero prices and negative prices?
Miguel, we should not, in my personal opinion, we should not take a static photo of what happened last week. People need to bear in mind that last week we had €0 per megawatt hour in the Iberian pool. We had to curtail over 2,500 megawatts, but not long ago, and actually it was 1.5 years ago, we were having prices of 200 or 300 euros per megawatt hour in the spot market, and the dispatchers in our dispatch center, they were like developing scenarios, extreme scenarios of curtailment, in this case not generation curtailment, but consumption curtailment. So we should not take a static picture or photo of what's happening now. We are having also a unique time in Portugal where the three main sources of renewables, solar, wind, and hydro, are on top. This is also not normal. What is normal is that when you have water, sometimes you don't have so much sun, or when you have sun, you don't have wind. So the combination of high levels of wind, sun, and water, it's not the most normal situation. So I think investors, they need to consider these scenarios because they are a reality, as we are witnessing, but they also need to consider other scenarios which are more favorable for their investments.
Georgios, does the Iberian Peninsula have what it's needed to reach the targets of the national energy plans? So globally, do you see that the regulatory conditions already exist or not, and the interest of the several stakeholders to move on with the projects?
I think it's under development. From our side, one of the most important things that we need to understand is that where do we connect? Do we connect offshore or onshore? Once this big decision has been taken, then things start falling in place because each party knows what need to do. For example, if we need to bring the grid onshore, then we need to make sure that we find the right solution. We need to make sure that we develop the supply chain for that particular application, and eventually that we make the whole schedule for delivering the project according to that.
But are you afraid that the political decisions will take a lot of time or not?
I cannot say that. I mean, it's. I think that it is not an easy decision. There are many elements, as we have heard just now, that influence this decision. I think from a system perspective and a more holistic point of view, it makes more sense that the TSO brings the grids offshore, so that's because then they can plan the whole system, integration of different forms of energy, interconnection between different areas, between different countries, in a more, I would say, sensible and more economic way, rather than going individual points. But taking that decision, the time frame, I don't know this one. We need to have it so that, again, we start putting things into place.
Professor João Peças Lopes, in your presentation you also had the map with the possibility of the Portuguese offshore wind farms could supply their electricity, their energy to the corridor that would come from the north to the south. But in that case, wouldn't how would it happen if that energy could be more in the interest of the Portuguese industry to take advantage of?
Okay. Let me just say something more about the curtailment that this issue, and then I will answer your question. I think, as Mr. João Conceição was saying, curtailment is something that is going to happen more and more in the future. And so this means that investors, when they build their projects, they need to start doing studies trying to identify the curtailment level. And there are two types of curtailment, the equilibrium curtailment and the technical curtailment. One is related to the fact that there is no consumption. And the other is because there are, in fact, technical restrictions in the infrastructure of the system. So all this can be done, ex ante, and trying to identify those volumes of curtailment in order to incorporate in the business models. So, and in this way, it will be possible to continue developing the projects, but incorporating an additional information, okay? Mm-hmm. So regarding your question, perhaps what the figure that was in the slides was not showing properly is that, so in fact, that backbone in HVDC was in our idea, was to be used not only to serve as an interconnector interconnecting the north of Europe to the north of Africa, but it was also serving to harvest part of the offshore wind generation. And at the same time, this also requires the connection to onshore. So from that interconnector, it is necessary to make connections to the HVAC network that exists, that is being exploited. And of course, it would be necessary to create a large connection in the area of Sines in order to not only to convey that electricity that is going to be or could be harvested along this interconnector, but also to deliver it to the main consumptions in the area of Sines. So like that, what the interconnector would do is that it would withdraw from the power flows that would take place onshore a certain amount of power that would flow through that interconnector and would be delivered directly in Sines.
Okay, Manuel, we are reaching to the end of this panel, but I'd like to ask you, how could the policymakers and the several stakeholders collaborate to enhance the grid design and the development of offshore wind?
Yeah, I also take the opportunity to go a little bit back because we talk about investors, we are investors, and I think it's important to share with you some thoughts on that. So we have identified this curtailment issue already long ago, 5 years. And since then, we are developing other type of projects, namely producing green hydrogen out of this renewable energy, exactly to somehow edge and control this challenge. It's really a huge challenge. And it is also a huge challenge to find solutions for this. So we can immediately think about battery storage, which is a nice solution for a couple of hours maybe, but with the level of investment we have, with the installed capacity we are discussing about, we need hundreds of megawatt scale storage capacities that could be available to store when we have excess and then to release when we need. So it's not only the arbitrage on the price, but rather on the technical side, trying to balance. So we cannot have pump storage everywhere. So these are projects that are also very difficult to implement and to permit. But there are other solutions that we are investigating, trying to combine with our Green H2 projects to do what Professor Peças Lopes taught us long ago, the demand-side response. So trying to balance the generation, the production with the demand. So what can the society, the public bodies, all the stakeholders do to implement these? These systems are very, very complex. They involve lots of different technologies that have different maturities. Some of them are known, others need still to be investigated further because we don't have, as Professor was saying before, for example, floating substations running for a couple of years. So we really need to be open to new solutions, be open to the new framework, and work together. So it was already said before that these systems have to be designed from an holistic point of view, addressing not only the single pieces of the puzzle, as João was saying before, but rather looking at the complete puzzle, and be open to different options. José Maria Lopes was mentioning that the option in Portugal right now is to connect all the offshore projects to the grid. Maybe it could be an opportunity to think, why should we take this as a solution? There could be others, and I am, frankly speaking, convinced that not probably tomorrow, but somewhere in the future, we can produce gases offshore, use the reservoirs that we have offshore to store, and try to find a system that could be self-balanced in a way that we could create a strategic energy reserve. As João was saying, the main focus of an energy system is the security of supply, of course. But we can develop these systems if we are open-minded. And for this, we need to be completely open to different ideas and to admit that it is not possible to run the decarbonization based in the same regulations, in the same energy markets as before. The past, based on thermal power plants, is over. So the market needs to be completely redesigned, and the rules have to be adapted to the new energy paradigm that is radically different from what it was 10 years ago.
Thank you very much. Since I'm not seeing questions from the audience, I would like to thank you for your participation and thank you for your interest.
Obrigada. Está terminada a parte da manhã. Agradecemos a vossa participação e esperamos que tenha sido do vosso agrado. Da parte da tarde teremos 3 temas em análise: Promoting a Happy Coexistence, Designing the Ideal Auction Model for Portugal e Reinforcing a Local Supply Chain to Unlock an Economic Opportunity. Passamos agora à pausa do almoço. O almoço volante será servido no centro de exposições. Para aceder, basta sair do edifício do auditório e entrar na porta à esquerda, devidamente identificada. Marcamos encontro novamente